Hi everyone. In this video, we are going to start adding and subtracting fractions. We're going to focus on both like denominators and unlike denominators. I have taught 7th grade for a long time, and I know typically middle school kids, well, let's face it, anybody, we tend to feel more comfortable with decimals than with fractions. But we are going to keep fraction problems as fractions. First of all, if you ever convert a fraction to a decimal and it's a repeating decimal or one that you have to round to work with, then the answer that you're getting when you do your adding or subtracting or whatever it is, it's not a precisely accurate answer. The other reason is when you take state standardized tests, chances are if they give you a fraction problem, they're going to want a fraction answer. So for the remainder of this chapter, for my students, for the rest of these rational numbers videos, if it's a fraction problem, we need to leave it as fraction. Okay? So the first thing we need to make sure we can do is rewrite fractions to have common denominators. If you're not familiar with that term, the top number of a fraction is called the numerator. The bottom number is called the denominator. You cannot add or subtract unless the bottom numbers, the denominators, match. Now you can look for what's called the least common denominator or the LCD. Least common denominator means the smallest number that both of the bottoms will go into. That's fine if you want to do it that way. I tend to try to use the least common denominator just because I know I'll have smaller numbers to work with. And who wouldn't rather have smaller numbers if it's possible, right? It also means that I might have to reduce or simplify less in the end. But it's okay to not use the smallest common denominator as long as you use something that they both go into. What I mean is this. If you look at your first two fractions, 3/8 and 1/4, looking at my denominators, 8 and 4, I know 8 times 1 is 8, and I know 4 goes into 8. So already I found a number that they both go into. But if you quickly look at that and you think, hey, 8 and 4 will both go into 16 or 24, or heck, even 8 times 4, you use 32. All of those are fine. As long as you're using something that they both go into, then it's going to be all right. But whatever you do to the bottom, you have to do to the top. If you change one, you have to change the other. So 3/8, if I'm leaving 8 on the bottom, I can leave 3 on top. 1/4, I'm changing the bottom. I have to change the top. To get from 4 to 8, I multiply by 2. So keep consistent. I need to multiply the numerator by 2. 1 times 2 is 2. 2/8 and 1/4 are equivalent. They reduce to the same thing. So now, whether I was asked to add or subtract or whatever I'm doing with them, now I could proceed with that because I have my common denominators. Let's do another one, just focusing on getting common denominators. The 5 and 4 for my whole numbers, I'm just going to leave there. But I need to rewrite the fractions with something that 3 and 5 will both go into. I know 3 and 5 will both go into 15, so I'm going to use that. If you had quickly thought of 30 or 45, that's okay. It doesn't matter as long as 3 and 5 will both go in there. To get from 3 to 15, I have to multiply by 5. So I'm also going to multiply 2 by 5, and I get 10. To get from 5 to 15, I'm going to multiply by 3. So I'm also going to multiply 4 by 3, and I get 12. There's my equivalent fractions. Now I could go on with whatever the problem's asking me to do. One more of those. I'm going to keep the -2 and the -1 because the numbers in front of the fractions don't need to match. They're fine. I need something that 10 and 4 will both go into. You might have said 40, which is fine. Use that. I'm going to do 20 just because they both go into 20 and that one's smaller, but it doesn't matter. To get from 10 to 20, I multiply by 2. So I'm also going to do 9 times 2 and get 18. To get from 4 to 20, I multiply by 5. So I'm also going to do 1 times 5 and get 5. Okay, so we've practiced getting common denominators. Now let's practice how to actually add and subtract the fractions, and then we'll put both of those things together. These problems already have matching denominators. So what we're going to do is keep that denominator and then combine the top numbers. And then, of course, we need to reduce or simplify the answers if it's possible. So on the first one here, I'm going to maintain my 15. On the top, I have 4 plus 1. That gives me 5. If you're one of my students, if you put 5/15ths on a quiz, I would give you half credit. Do you know why? Because 5/15ths, I can divide them both by 5 and simplify that to 1/3. My final answer on this is 1/3. On the next problem, I have an 8 for both denominators, so I'm going to keep 8 for my denominator. On the top, I have 7 minus 1, which is 6. I can reduce both of those by 2, and my final answer is 3/4. On the next one, they both have a 10 on the bottom, so I'm going to keep a 10 on the bottom. On the top, I have a -3 and a +6. We are still going to use everything that we learned about integers, positive and negative numbers. If you find that you are still struggling, add, subtract, multiply, divide, negative numbers, please go back and check out those videos that I have on here for integers. You need to master those before you can do all of this because it's just building on those concepts. So -3 and +6, I have 3 more positives than I do negatives. So 3/10. 3/10 does not reduce, so that's my final answer. And then the last one here, they have a 6 on the bottom, so I'm going to keep a 6 on the bottom. On the top, I have a -4 and a -1, but that -1 is just a negative one. I've got -4, -1. Altogether, I have -5, -5/6 for my answer. Let's do a few more of those to make sure we've got that down pat. So I'm going to keep the 9 on the first one. 7 plus 1 is 8. 8/9 does not reduce. You know what might be a good idea if you're learning this for the first time? Consider pausing this video, try the problem, and then watch for my answer and see if you match. And if you don't match, and with my explanation, you're still not sure what you're doing, that's when I would encourage you to reach out. My students, I would encourage you to ask me again in class or send me an email, reach out to me on my classroom Facebook, post a comment here. Don't just kind of blindly say, I'll get it later. Actually try it. Math is about trying. It's about the practicing if you ever really want to get good. So think about that. Think about pausing and trying here. Number 2, I'm going to keep the matching 5 on the bottom. On the top, I have a -2 and a +4. I have 2 more positives than I do negatives. So 2/5 is my answer. Number 3. Okay, now here's where we're going to start putting these together. I do not have matching denominators. So what I want to do first is rewrite these so that the bottom numbers match. 10 and 2, you could do 20 if you want to, but I know they both go into 10. So I'm just going to go ahead and rewrite these with a 10 on the bottom. The first one, I didn't change the bottom, so I do not change the top. The second one, I did change the bottom, so I do change the top. To get from 2 to 10, I have to multiply by 5, so I'm also going to multiply the 1 by 5. So really what I'm doing is 9/10 plus 5/10. I'm going to keep that 10 on the bottom. And now like we did on problems 1 and 2, I'm going to combine the numerators. 9 plus 5 is 14. Don't circle it and call it done until you've reduced. If I divide both of those by 2, I get 7/5. Now I know a lot of teachers have different opinions on this. My opinion is that it's okay to leave them improper where there's a bigger number on top. as long as it's reduced. When we get into the unit on working with equations that have fractions, it's going to be a lot easier for you if they are improper. So I'm okay with seeing that now, with going ahead and doing it that way. However, if it's a word problem, I would recommend changing it. If you're going in and you're trying to tell someone in a hardware store the size of something, and you say, yeah, I need 7/5 feet, they're going to look at you like you're an idiot. So in that case, I would convert it. If you're taking a standardized test, or if you're taking a multiple choice test and none of your answers are written in proper, then yeah, you do need to know how to convert it. You need to know how to go both ways. But otherwise, I'm okay with seeing the 7/5. So what I'm saying is leave it. It's okay. If you convert it, 5 goes into 7 one time. 5 times 1 is 5. So you have 2 left over. So 7/5, or on a multiple choice, it might be more likely that you would see 1 2/5. Sorry, I know I rambled a lot in that. I hope you stuck with me and that it made sense. Okay. Number 4, I've got a 7 and a 3. I know 7 and 3 will both go into 21. So I'm going to rewrite both of these with the 21 on the bottom. To get from 7 to 21, I multiply by 3. So I need to multiply the top by 3, and that becomes 9. To get from 3 to 21, I multiply by 7. So multiply the top by 7, and that becomes 14. I'm going to keep the 21 on the bottom. Now on the top, here's where, again, you really, really need to be comfortable with those negative numbers. So feel free to check out my YouTube channel, Math with Luger. I've got a video on there about all this. But if I have a -9 and a -14, if I owe 9 and I owe 14, then I owe 23. So -23/21 is fine. Or 21 goes into 23 one time with 2 left over. So -23/21 or -1 and 2/21. 2 more. 16 and 3 are my denominators. I can't do anything with them the way they are. So I'm going to rewrite these. Let's see. 16 times 1 is 16. 3 won't go in there. 16 times 2 is 32. 3 won't go in there. 16 times 3, well, obviously 3 will go in there. I'm going to use 48. 16 times 3 is 48. So on my first one, to get from 16 to 48, I multiply by 3. So then I'm going to do 1 times 3 and get 3. To get from 3 to 48, I multiply by 16. So then I'm going to take 1 times 16 and get 16. That was a lovely 6. Sorry. Okay, so back with those integers again. We call these face problems in my class. Or when you've got a minus and a minus, to take care of that, to simplify it, they come together to make a big plus. So I'm going to keep the 48 on the bottom. And on the top, 3 plus 16 is 19. 19 and 48, those two numbers are relatively prime to each other. It means it cannot be reduced. There's nothing that goes into both 19 and 48. So that is my final sum. Last one, 12 and 9. I could do 12 times 9. I could use 108. Or I'd rather use smaller numbers, especially when I've got, like 11s and 12s here. If I go through the multiples, 12 times 1 doesn't work. 12 times 2 doesn't. Oh, wait, 12 times 2 does work. 12 times 2 is 18. Here in my mind, I saw 36 for some reason was the first one I thought of. If I had used 36, that would have been fine. They both go in there. What am I talking about? 12 times 18. Okay, guys. See, this is where you should not be recording a video for YouTube when you're tired, because obviously I'm tired. But that's okay if you're still hanging with me because everybody makes mistakes. And my students already know I'm a big dork. So we are just going to rewind and pretend like that last 2 minutes there never happened. Okay. How about 12 times 2 is 24? 9 doesn't go into 24. So no wonder I had 36 on the brain because 12 times 3 is 36. And that is the smallest that they go into. Man, if anybody is watching this who doesn't have me in class, I swear I'm a smart person and I'm a good teacher. I just have these space cadet moments, but don't we all? My gosh. Okay. Embarrassing. Moving on. So I'm going to rewrite both of these with 36 on the bottom. Oh, for goodness sakes, I swear. Okay. So 12 times 3 to get to 36, right? So then I'm going to take 11 times 3. And I get 33. Don't forget that negative sign. 9 times 4 to get 36. 4 times 4 is 16. Again, don't forget that negative sign. Minus, it's face problem. You've got your 2 eyes and your curvy nose. Those come together to make a big plus sign. So I'm going to keep the 36 on the bottom. On the top, so what I see there is a negative 33 and a positive 16. I owe somebody $33, but I only have 16, so I don't have enough to pay him off. So I want to ask myself, how much am I short? I'm short $17. I have 17 more negatives than I do positives, so negative 17 goes on the top. My goodness. Thanks for hanging with me. Sorry I had my total space cadet moment in there. If you need any more help, I swear I don't do stupid stuff like that all the time. Check out my other videos on my channel. It's Math with Luker. If you're one of my students or a family member of one of my students, I do post updates on my classroom Facebook. It's Luker's Math Class. There's my school email. See, now I can't even talk. Oh my gosh. School email if you need to get a hold of me or leave me a comment on this video and I'll get back with you. Thanks again for hanging with me. See you next time.